Hello and welcome back. This is the second video in a series of APP tutorials. Today we'll be going over mission computation files. The first video we went over aircraft files and how to set those up. If you haven't done so, go ahead and watch that video first because we're going to go ahead and use that aircraft file in this mission computation file. So if you haven't watched that one yet, go ahead and do that and come on back. If you have, well, let's go ahead and get started. To instantiate a mission computation file, we're going to go ahead and create a new one in the drop-down. And as you can see, you're going to be prompted with a general information tab, just like the aircraft file. And we're going to populate the mission name dialog with APP tutorial. The author is going to be Dar Corporation. And of course, the comment section for any mission profile specific comments that the developer needs to make. And next, we're going to select an aircraft, and we're actually going to select the aircraft that we created in the first video, the single piston engine aircraft. And notice that all of the general information that we filled out in the aircraft file actually populates in the fields below. So next is going to be the settings tab. And the settings tab is more of an initial condition tab than anything, because we are going to select the initial configuration, which for this aircraft, since there's only a single clean cruise configuration, that's the only option here. But if your aircraft has more configurations, they will populate in here and you can select them as needed. But we're going to select clean cruise. The starting point for us is going to be at sea level, initial velocity of 0. And note that the Mach and velocity line edits are actually coupled. So if you want 100 meters per second, it's actually going to change your Mach number depending on what you put in here. But we're going to start at 0. And the same goes for fuel mass and fuel percentage. So if you want 25% fuel, it's going to adjust your fuel mass accordingly. But we're going to do a full fuel. And of course, the same goes for payload. So if you want 25% payload mass, it's going to adjust your total payload mass and then give you the corresponding mass of the aircraft. Now, we're going to do this at full capacity and move on to defining our segments. But before I move on, I do want to mention the external stores dialog over here. Like I was discussing in the aircraft file, if you were to define any stores, this is where you would attach them and toggle their state. And then I want to address the atmosphere dialog. This is where if you have anything other than the international standard atmosphere that you want to define this mission, you can browse and select it here. You can also create your own atmosphere file by going up to File, New, and then selecting an atmosphere. And this will open up the atmosphere creator that APP has. And then once you save it, you can browse and then add it to this mission file. But we're going to go ahead and move on to our segment list. And this is where we're going to define each segment of our mission profile. And our mission profile is going to have 7 individual segments: ground operation, takeoff, acceleration, climb, cruise, descent, and a landing roll. So we're going to go ahead and select Add and find Ground Operation and hit OK. And notice how we have 4 distinct areas of this page. Excluding the segment list on the left, we've got the Segment Stops At dialog box, the Time Step dialog box, and the bottom one with Power Setting, Thrust, Engine Revolution, and DT box. And then the last one is Tools on the far right, which I will get to in a minute. So we'll start with Segment Stops At, and this allows the user to select when the algorithm goes on to the next segment number. There are many different options under the Segment Stops At dropdown. But we're going to stick with segment time for this one, and we'll get to other ones in later segments. And we'll say that a normal ground operation is maybe 5 minutes, and note the units on the right here. The time step Usually the default is a good value. We're going to keep it at 10 seconds. The power setting during a ground operation is probably around 30%. Our thrust is going to be 0 because we're just going to be sitting there. Engine RPM might be around 1,000 RPM. And DT we'll say is 0 Kelvin. A few things to note. The configuration of the first segment will always match what was indicated in the initial condition in the settings tab. If the user wants to change that configuration, you can select that segment, hit replace config from the tools, and select it from the dropdown. Another important note is that you can indicate a or segment stop. So let's say you want to stop at a certain true airspeed. You can indicate that in addition to the original segment time of 5 minutes. Now, that doesn't necessarily make sense for this case, but we'll get to more examples of this in later segments. So the next segment we're going to add is a takeoff segment. So go ahead and select add and scroll down to takeoff. Hit OK. Now notice how APP doesn't let you select a stop criteria for the takeoff segment. It is going to calculate a stop criteria for you. So you can populate the time step dialog and the power setting dialog with the necessary values, but the stop criteria will be taken care of by APP. So the power setting is going to be 100%. Engine RPM is probably going to be 2400. And notice how the thrust and engine RPM are coupled. The climb angle, climb speed, and DT will remain 0. The next segment we're going to add is a climb segment. So go ahead and select add. And notice there's actually multiple climb segments. We're not going to use any of these right now, but these optimize for the item that they name. So climbing at calibrated airspeed, climb at best angle, best rate, etc. We're just going to use the generic climb segment. And note how the segment stop criteria defaults to an altitude. You can still change this to whatever you want it to be. We're going to keep it at altitude, but we are going to change this to 2,500 meters because 11,000 meters is really high. So we're going to keep the time step at the default value, but the distance credit and altitude credit, let's say you didn't want to account for the takeoff distance in your overall profile. You just check that value and it won't integrate in the X position for the climb segment or the takeoff segment. But we're going to keep those all checked for now. The power setting is at 100%. The thrust is going to be coupled with engine revolution, and we're going to climb at max power. The acceleration will maintain 0 for now, and the DT is 0. So the next segment we're going to make is a cruise segment. So like the climb segment, the cruise segment has a lot of different variations. But we're going to go ahead and just stick with the generic cruise. The default segment stop criteria is a segment distance. We're going to 10 kilometers pretty low, so we're going to make it to 50. And then the time step is going to be 60 seconds. So with cruise, since we're assuming that the entire cruise segment is basically the majority of the flight time, it's going to be pretty unchanging. We're not changing altitude. We're not doing any maneuvers. So the time step can actually be fairly large. 1 minute isn't bad. But for items that happen to have a lot of variation within them, you might want to adjust that time step. But here we'll just stick to 1 minute. Engine to RPM, we'll say we're cruising at 2200 RPM. Load factor 1. We're not turning. We're not accelerating yet. I'll come back to that. Climb angle, climb speed, and DT will all remain 0. So after cruise, we're going to descend. So we're going to go to add, and just like climb and cruise, there are different variations of each, but we're just going to do a plain old descent. And the default segment stop criteria is altitude, and it goes down to sea level. We'll go ahead and keep that. Time step is 5 seconds. We'll keep the default there as well. We are going to account for both the distance and altitude in the integration. Power setting will drop down to 15%. And engine RPM will have a little bit, so 1400. And for now, no acceleration and no DT. And the last segment we're going to add is a landing roll. And the landing roll is going to lock you in at a velocity of 0.01 meters per second as the primary stop criteria. The time step is going to be much finer than the other ones at 0.1 seconds. We're going to keep that as default. We're going to have a 0 power setting and a little bit of engine RPM, but no excess thrust. Climb angle, climb speed, and DT are going to go ahead and remain at 0. So what we're going to do next is see if the current state of these segments results in a successful computation. So we're going to jump over to the Computation tab. We're going to keep all the default settings for the computation type, the solver. We're not even going to deal with advanced computation. We're just going to hit run. And this is going to result in an error. CL is greater than CL max at segment 3, or our climb segment. I take this as our takeoff speed, which now you can see has been calculated for us at 38 meters per second, isn't fast enough. And so we're hitting our CL max trying to climb, thus the error. So to fix this, we're going to have to insert an acceleration phase between the takeoff and climb. So you go up to insert, and we're going to select the acceleration at the top, hit OK, and then that creates an acceleration phase between takeoff and climb. We're going to set the velocity as the stop criteria, and we're going to set it to 50 meters per second. And we're going to go ahead and set the power setting to 100. The engine revolution is going to be 2400. Load factor will remain at 1. Turn rate will remain at 0. And climb angle will also remain at 0. But let's say we have a little bit of climb speed. Let's say we have about 1.5 meters per second climb speed. And then we'll go ahead and computation, hit run. And you'll see that it has successfully run with these changes. So if your mission file executes correctly, you should see your results tab with the chart pop up first. That means that the computation computed without error. Doesn't mean the results are what you're looking for, but you set up the file such that it doesn't throw an error. Now, you can change the X and Y axis to see the data in certain ways. The X-axis will remain constant here for these buttons over here. So if you hit Mach, it's going to give you distance as a function of Mach, as you can see, or CAS, or fuel, etc. These presets over here are XY presets, so distance out or time and out. The results chart tab is great for spot checking data because it allows you to change up your plots and look at different variables of your output. But if you need a detailed output, go to the results sheet tab, and this will provide the actual data of the output. And if you need a more detailed output, go up and select detailed output from the drop-down menu, and this is going to give you a time step by time step value for each variable. Let's say there is a parameter that is not present in the default parameter list here. There are more options. So to add to this list, you're going to go up to the options gear. And there's a tab, Mission Param. And on the left side, you're going to see the complete list of variables that you can add to the list. And on the right is what's actually in the list. So to add, let's say you're going to add true airspeed. You're going to select it, and then you're going to hit add, and then you'll hit OK. And if you scroll all the way to the right, you'll see that it's been added to the list. So that's going to do it for this video. If you have any troubles or if you need any help, if you go up to the help drop down, it's going to provide you the technical reference and the online manual. But other than that, I'll see you guys in the next video.